It's not doing it. Big thing in freshwater, dissolved gases. Oxygen is a huge thing. The colder the temperature, the higher the oxygen. Lower the temperature, sorry, did I say that right? No. Colder the water, higher the oxygen that is within that. And you have to remember, fish species, for example, they need a good 8 to 12 parts per million to thrive, which means that's surviving, reproduction, growth, everything. Now they can survive, which means they can live, but they're not able to really grow or anything at about 4 to 5 parts per million, but they're not able to really sustain their population at that level. So that's where oxygen is very important. Also, phosphorus in freshwater environments is a limiting factor. It's really, plants require the phosphates going in. Problem with fertilizers or using soap products, as Heather had said. The biggest problem with that is you're throwing all these phosphates in, you end up getting algal blooms and stuff. Also, the coolest thing about freshwater, at least I think, is that you can do it in marine as well, but I've always found that it was a lot more fun for the variety, is that you can determine your water quality by way of macroinvertebrates. So, bugs. And these are larval forms of terrestrial bugs. We have the tolerant group, and you guys will probably be going through this. But I do know that in the test we do have an activity where we talk about the importance of biological monitoring. And basically group 1 are the insects. All right, macroinvertebrates real quick. You guys all know where they come from, right? All right, so what is a macroinvertebrate? What? A big invertebrate. Excellent. All right, so as I'm like running through all of this stuff, I realized that, most of you haven't done it because you haven't quite gotten there yet. All right, so pretty much a macroinvertebrate. In this case, in our streams, there's several insect types, such as mosquito larvae. Everybody likes mosquitoes, right? So mosquitoes, caddisflies, dragonflies, stoneflies. Well, basically, they all start out their life in the water, in the benthic being underground, water, and in the ground. So basically, what scientists have discovered is that some of these guys are tolerant to pollution and can handle it, and there's other ones that cannot. And those that can't, they require cold water, lots of oxygen, and they're non-tolerant of any type of pollution. Those are the caddisflies. They make their cute little case that they can carry around with them. The stoneflies, helgramites, and mayflies. And then group 2, somewhat tolerant, require a little bit less oxygen, dragonfly, nymphs, so on and so forth. And then our least favorite, they are the ones that can tolerate lots of pollution, as well as low oxygen. So those are our leeches, our mosquitoes, our black fly larvae, so on and so forth. So that's really what I kind of wanted to talk about by way of freshwater. You can determine by looking in the ground what water quality you have. And then we have the estuaries, but we're running out of time, and I really want to get to the watershed model. So real quick, estuaries, basically where the freshwater meets the saltwater. And basically what's really cool about the estuaries is that they're highly productive. 22 out of 32 of the world's major cities are on estuaries, including Providence. They pretty much are right there. That's where our ports are. Also, what's unique about them, a lot has to do with the density gradient of the salinity gradient, where salt water meets, and they don't mix nice. They actually, the salt water drops down underneath, so in narrow river in the spring, in the fall, great time for striped bass. and you're actually in what you think is fresh water, but salt water actually goes underneath, and you can actually find crabs and different types of saltwater organisms on the bottom, and you'll see freshwater organisms on top, and that's the salinity gradient. And that's really one of the most fascinating things I feel by way of organism distribution. But we have this on here. You'll see that when you look at the PowerPoint, you'll see notes. They're kind of crazy, but if you look up some of the stuff that you see on there, you'll get an idea of a little bit how important everything is to intermixing. Yeah.
Last year you wanted us to know a fair amount about aquatic plants. Are we should we say that this year or not?
We're basically trying to go down. We're revising it a little bit. The big things that we definitely want you to know are the limiting factors in both the freshwater and saltwater system. It was more or less dependent on the topic of estuaries the last time, whereas we really kind of wanted to let you know about the rhizomes coming up through the estuaries and estuarine plants, and that's how they're adapting to salt water, but not so much this year. Other than that, I'm all set.
Right, my intro around the groundwater and
All right. Well, what time is it? Okay. All right. We don't want to go too crazy, but no. we did want to talk about what the aquifer is, because an aquifer is kind of one of those. And we talked about groundwater and surface water. So we have this model. All right, so an aquifer is pretty much the gravel in the system where all the water is drained down and percolates through, and that pretty much is, we're talking filtering. It's a filter, a natural filter where it percolates down, and then you have the groundwater that comes in. This is where it's really important that of what you're putting into your waterways and what you're putting into your wells. How many of you have natural wells at home? All right. How about those of you who have city water? Or you're connected to a sewer system? All right, so your sewer system, that pretty much, you get your water from the town, you have to pay so much per gallon that you use, and then you turn around and it filters back through. All of your wastewater grade water goes back into a nice little plant that takes all of it and replenishes or gets all the microbes and all the bad stuff out. Well, in well water, what happens is this. Basically, whatever you put on top of that soil gets drained right down through to your aquifer. So.
All right, so I'm going to just basically demonstrate the basic concepts. If you can't see it, feel free to stand up, move around, or whatever, because this is a great visual thing to really put together some topics and for you to see some connections. So there's some food coloring water. I poured water into this. So we have a line here, obviously. You can see a line of blue water. Does anyone know what we might call the top of that water, the line of blue water? We're looking at the ground level is here, the surface of the ground. What? Go ahead, blue sweatshirt, blue shirt. Right, so right here, this line, the top of that, which is not shown. This line right here, this is going to be our water table. Above the water table, where we have air in the pores, in between, the gravel, the sand, rock, whatever we have here. So this is the zone of, anyone? Where plants grow. Zone of aeration, okay? So this is where we have, it will become saturated as it rains, okay? It will become saturated. It's raining. What do we see happening to the blue? I don't want to put too much in. It takes a lot of pumping to get out. Does everyone see how the blue line is now above the first line that I drew? Okay, so we added rain to the system. That water table is now higher. Okay, now we have a new water table. Now it's up into the zone of aeration more. So this is where the plants are growing. So they're getting air, they're getting water. Now, you can begin your pumping. So over here we have a well. You probably should notice that the water table in the well, or the level of the water in the well, is the same as the water table over here in the ground. Below our water table, so we have zone of aeration up here. Down here we have the zone of saturation, I heard. Yep, zone of saturation. So this is our aquifer below the water table. The water table is the line that divides the zone of aeration and the zone of saturation. Again, we have our well over here. And so our friend over here is pumping from our well. He is, he's our golf courses. He's our farmers for agriculture. He's our individual homeowners. He is, the businesses. Everyone who's using water from our landscape, he's pumping water out of that well. Now, it takes time. Hopefully it's working. Just don't pump it past this point. Okay. Just like here, because if it gets up into here, it'll get into the vacuum. So just as it starts to get close, you can stop. So what I'm noticing, and it might be harder up there to see, is so the water level was here at the blue level. That was our new water table because we were adding to the system. It was raining. We had a lot of precipitation, a storm. So now with use and no rain, you see that the water table is now coming, the blue line is now slowly moving down here. So if we're not adding to the system, if we're not getting a lot of precipitation, but we're using a lot of water, we are now taking from the system and we have less. So there's less water for everyone to use, whether it's animals, plants, humans. So my question to you, you can stop pumping now. I'll need you again, but you can stop for now. Thank you. Have any of you ever seen the water table? Not you. Okay, maybe, maybe not. So some of you you might not know. So I'm going to make, I'm changing our landscape a bit. All right. No, but I know people there. In fact, I used to work there, so I know a lot. All right, so I have now created a depression. Okay, I've changed our landscape. And so now you can probably see even better that he pumped enough water so that we're actually below our original water table that we started with. So what I just drew, the red line, we're all seeing our water table. Okay, here's a pond. I created a pond with a permit. And we can all actually see the water table. So now there's that connection between the groundwater and surface water. When you're looking at a pond or stream or whatever, that is the water table, the top of the zone of saturation. So it's a hot summer. We're not getting a lot of rain. Feel free to pump. Okay, so we are, so we are maybe a farmer, and he is next to this pond. And he obviously needs to provide water for, if he has animals, he needs to provide water for the cows, the pigs, whatever. Or if he's growing crops, he needs to irrigate that. So as he is irrigating and he is using up some of the groundwater, we will, over time, see that water level drop. Okay, so not only are we changing the level of the water table in the ground, but he will also notice on his farm that the pond is lowering as well. Now, we can always change that. We can't technically do it, but Mother Nature can always change that, by raining or what, especially, like Kim was saying before, all of the snow that we've gotten over the winter. That always helps. We have a lot of, hopefully, groundwater to begin with for this spring season. So we've added more water to the system. You can keep doing that. Now, I'll try to do this very quick. So now this is going to represent some pollution. So it could be pesticides or something if we're going to stick with the farm theme. The farmer's using a lot of insecticides or pesticides or whatever, maybe excessive fertilizer.